thing. It's like a quotation.
Yeah.
But a ditto mark on tomorrow would mean it's the same thing. So if you have time today to get this done, you can get today and tomorrow. I mean, it's one homework assignment for today and tomorrow. So 8 through 17, we're going to make this lesson. And not make, it's a big lesson. So this lesson will take 2 days. And I know a lot of us still need to finish the test. We're going to do that tomorrow, most likely. I sometimes like to give you guys some feedback between like the first test day and if we have to continue and finish on the second day, between those 2 days. So I want to take some time with your assessments tonight to give you guys some feedback, and if there's stuff like, you know, if you've made a mistake and I want you to look at it again or whatever else, we'll finish those tests later in the week. They won't go on math until you have them back. Bless you. Kind of a thing that I do is like I want you to know your grade before your parents know your grade, right? Because it's your grade. So I give you guys your tests back before they go on that. Any other random questions?
I'm very spasmy today, so you're gonna be like.
Maybe need to get up and go to the back room and do some jumping jacks or whatever. Do that. So I'm gonna zoom a tiny bit more. I think that's still kind of small to read up there. Anyone feel like reading?
Me.
Who's me?
Aiden.
Aiden, go ahead and read for us.
In the previous lessons, you explored different representations of portions, parts, of whole. You look at portions represented as fractions and as decimals, and you went back and forth between the representations. While fractions are written in a common format, that is, as the quotient A, B, where A and B are in.
Now pause a second. Integers. What does integers mean? We talked about this last chapter, but they say A and B when we use fractions have to be integers. Riley?
I think that they're like the opposite on where it's like the negative and positive.
They involve negatives and positives, yeah.
They're like the same except they're on different sides of it.
Yeah, but there's a bit more details that we need to make sure that we have that definition covered. A over B being integers. All right, in your notes, if you haven't put a header on it, put a header on it. Guys, why do I have people that don't even have a sheet of graph paper out? We've been in school for a month now. You know that when you come to math, you need that graph paper out. It's also up on the board that says have out. Math binder, which means your graph paper. If you want to put your binder away, that's fine, but if I was you, I'd probably just keep your binder out. It's like, Mr. Pearson, I should not need to be inviting you to get out a piece of graph paper, although I know you were reading, so it's okay that you're behind. But, guys, we should, like, come on, you know this. I should not have to ask us to get out graph paper. That's just part of our processes. And I have tons of it. There's a stack in the back, there's a stack right here, there's a stack over there, I have a lot. So, integers, and if you haven't labeled your notes, fraction to decimal, and as we did last chapter, you can abbreviate. Frac to dec. You can head your notes with that. You can just have this say 2.1.1, or you can name it fraction action.
More fraction action.
But it's not just fraction action, so it's fraction action with decimal.
Dynamics.
Sure. Dynamic decimals and fraction
Oh
action.
yeah.
All right, integers. So we need to put in our notes, please, integers. I-N-T-E-G-E-R-S. I'm going to give you the real easy definition. Entire values. That's it. That's what integers are. Entire values. Hang on just a second. So what that means is no partials, no fractions. So you don't put a fraction in a fraction, and no decimals. In a fraction, we do not put a fraction in the fraction, and we do not put a decimal in the fraction. 17. 9, 17. All day long. All right, Aiden, question?
So how long does it usually take us to do like a whole like?
It depends.
Like usually
Yeah.
like a month or something?
It all depends. It really does. We missed a few days here and there in the first month of school. But I mean, for what it's worth, we have, I believe it's 9 or 10 in this textbook. We have like about 10 chapters. So we should move a little quicker than a month per chapter, but not terribly. So integers are entire values, right? Now it doesn't mean that you cannot put a fraction in a fraction or a decimal in a fraction. It's just wrong. We don't do it. It's like, it's not appropriate. All right, so Aiden, you want to continue?
Sure.
When we make fractions, they are integers.
Their decimal representations have two types, terminating and repeating. Why does this happen? In this lesson, you will work with your team and determine what makes some decimals terminate and some repeat.
Thank you very much. All right. On your graph paper, now my advice if I was you is use the boxes on your graph paper. Make 2 rectangles. Now, if you really want my advice, make it 6 wide and like 2 or 3 or 4 tall. Like make it 6 boxes wide, big enough so that you can actually work with it. Because the first one, we are going to split into thirds. So I'm going to switch and show you my graph paper, and I'll do it on there. So,
8 is 9 slash 17 slash 18.
split this into thirds.
Yep.
I didn't go wide enough.
I was gonna say something.
It's Monday morning. Counting's hard. And shade 2 of them.
That's why I said Mr. Phillips was like, it's too hard to take in the morning.
Now, take a moment. Don't talk with your group. I don't say that very often. Don't talk with your group. Write the verbal explanation of what you see. Like, with words. How do you explain what we see? Write it on your paper. There are multiple right ways. But for this rectangle, how do we write what we see? You have a question? Maybe you have a
I
question.
write multiples because
I bet most of you wrote one of those two.
No.
2 out of 3 or 2/3?
I wrote 2 shaded out of 3.
2 shaded out of 3, right?
I wrote 2
Sorry, what?
I wrote like a 2/3 of the rectangle.
2/3 of the rectangle are shaded, 80?
There are 2 shaded out of the 3 pieces of the whole.
There are 2 shaded out of the 3 pieces, okay.
Out of the whole.
Thank you.
I see 1 hole made into thirds and 2/3 are shaded.
I see 1 hole cut into thirds or made into thirds. 2 of them are shaded. Nice, even. Ooh, a rectangle divided into thirds and 2 are shaded. So, this, if we write it mathematically, right, becomes that. But one thing we've been working last week and last chapter is that if we can turn this into something with a 10 on bottom, it'll nicely become a decimal. What else could be on bottom to nicely become a decimal? 100, 1,000, 10,000, a billion, sure.
A trillion. A quintillion.
So, does this happen nicely? Is kind of what we ask ourselves.
No, it's so annoying when it doesn't happen nicely because then you have to do stuff.
So, this, in decimal form, we're actually going to skip over that fraction form. I'm just going to give you this one. Now, an evil math teacher, I sometimes think, what would life be like if I was evil? I'd maybe have
I'd be
like $1
really
billion.
sad.
And and share.
Right, an evil math teacher might ask you to do this long division.
Oh, I hate long division.
And if you start that long division, I don't know if this is too old or not, but I wonder if anyone knows this. This is the song that never ends. It goes on and on, my friend. Some people started singing it, not knowing what it was. And they'll continue singing it forever just because this is the song. No? Nobody? Come on! Is this, yeah? Who knows that?
It's a Monday. It's tough.
What's it from? Who knows what it's from?
I don't know.
So, this is from a really old kids show.
Sesame Street.
No, older than that. Mr. Smith, do you even
Older
know?
than Sesame Street,
I
that's
know
not
the
a
song, but I don't know what it's from.
So they had it in what's it called? It's lamb. There was like a lamb puppet, and it was something like Lamb Schultz. No,
The Muppets?
Lamb Chop.
There was a show about
Yeah, I'll look it up. But so guys, this is why we don't like long dividing.
I hate long
Because if you start long dividing this, you will continue doing this forever. This is what we call a repeating decimal. So if you can't quickly tell me that's a repeating decimal, I need you to write that down, please. So go ahead and jot on your paper repeating decimal. And I know we talked about this a little bit last week. And this is called the repetend. I know it's a weird word, but this is the repetend. Now we also can use ... and you can actually put like 4 or 5 or 6. I mean, you really only need 3. Anyone remember what that's called? Did we talk about this last week? The last chapter. Starts with an E. It's like the thing you looked at in the sky last year, but it's not. It's an ellipse. So, both in literature and in math, 3 dots just mean this keeps going. Right? So if you use that when you're texting a friend, you're like, yeah, he said he likes me and he complimented my hair and then...
And then he told Rebecca he liked her.
Oh my gosh. So, ... just means like, yeah, and there's more. There's more to this story. Now draw another box. Draw another box. Or you already did it. You might have already done it. Divide this. Divide this into 4 pieces. Now, if you made your boxes 6 wide, this is going to be awkward because it won't line up correctly.
Growl.
Growl, yes, growl.
Growl.
Shh. And then write on your paper what you see, how you would explain this. You know the drill. We just did this.
Yep.
And I guess if you want to, so there's really this weird rule about when you use the number and when you write out the word for the number. It's essentially like if you're below 7-ish, you write the word, and then if you get more than that, you normally just write the actual numbers.
Like your age? Age 7?
So if you're writing, right, you're texting, you're typing a paper, you're doing, and you're debating what do I type the numbers or the word? There's like this weird rule for like small numbers, you should write the word.
Oh,
Yes.
like the number 7.
Yes, like the number 7, number 8, like then you start to like you just put the especially double digit, triple digit numbers. We're not going to write out like 174. We'll just put 174. So 3 out of 4. Right, 3 shaded out of 4. 1 hole broken up into 4 pieces. 3 of them are shaded. This is like when my wife and I split a pizza. I'm gonna take 3 of the 4. No, I'm joking. But 3 out of 4, right? Now this, I would not be an evil math teacher if I asked you to long divide this, because now we're not gonna long divide still, because you know, as I said, I'm opposed to long division. If we look at 3 over 4, hold on. Go ahead and write this on your paper if you would. Does this easily turn into 10?
Yeah.
No. Right? A couple people instinctually said, yeah. Hold on. Does it easily turn into 100? Yes. So show the work. Do that. Multiplication, that division, whatever you're doing. How many 4s does it take to make 100? 25. And if we did it on the bottom, we had to do it on the top. And we get
75.
Now, was it someone in this class that we ended up talking about Freddie Mercury last week?
Yes.
Yeah, okay. So weird connection. Sorry, it's a Monday. My brain is 8 places. Freddie Mercury ended up in this odd movie called Commando with Arnold Schwarzenegger.
Oh, yeah, you told us.
Arnold Schwarzenegger is most notoriously known as the Terminator. And that is because he ends people. Right, yes. Get to the chapter. But this, because the decimal does not continue going, now, that's a dangerous statement. All numbers keep going forever, every direction.
Yes.
But they're all zeros. Right? There are infinitely many zeros to the left of this. Joey is not amused. And there are infinitely many zeros to the right of this. So this does keep going, quote unquote, but it's zeros. So this is a terminating decimal.
Terminator.
Just like the Terminator, because it ends. So please jot down in your notes real quick, terminating. Terminating.
T-R-T-E-R. You said T-R.
Oh, sorry. Terminating.
Wait, was the last one decimals and percentage? Now it's decimals. I mean, no, fractions and percentage.
I wrote.
So today's, today, tomorrow's, we're mainly looking at converting fractions into decimals.
My header right now is fraction meets dynamic decimals.
Nice. I'm going to have to take a picture of those notes.
They're pretty great. They have rainbows.
All right, so in 115, we talked about 1/9. Right, I'm going to scroll this back down for a minute. And we started talking about some rules. Can anyone look at the 1/9 fraction and remind us of the rule involving ninths, or when there's a 9 on the bottom? Joey, you're taking me on a roller coaster of emotions.
Yeah. So what number's on top? That's the number that repeats.
Yeah, say it again, but louder.
Whatever number's on top, that's the number that repeats.
When working with a 9 on bottom, which means division by 9, whatever number's on top, that repeats. Now, I got a challenge for you. Sometimes after our staff meetings and team meetings and everything else, our team will go out and grab like a bite to eat or something because, lunch is weird on Fridays. So we go out after work, and unfortunately there's only 5 of us, right? There's 5 of the 7th grade team. Maybe Mrs. Pettigrew had to go home to her kid or something. But there's 5 of us, and we order mozzarella sticks.
Oh, I
Right?
love
Who
mozzarella
doesn't like cheese sticks? Now, unfortunately, 13 show up. And Mr. Smith and I immediately realized the issue. We want to be equitable, and we want to make sure everyone has the same amount of cheese sticks. But there's 13. Gross number. So, with your team, I need you to tell me how much will each of us get? Take like 2 or 3 minutes to talk with your team about this. Nope. We're eating all of them. We're hungry. You guys
Okay,
want
then
us
take
out.
one for yourself.
Nope.
Give one to me.
Or fair.
Okay, then
Here, where's
split
the other
one
one?
in fair.
Where's the other one?
Hey, and what is
Riley, did you steal my jelly?
What?
Alright, well, if you find it, let me know. I'm coming later. Oh, my heart is broken, Joey. Why would you ever make that choice?
Joey, what?
That's Joey.
Is there another thing? Hey, no need to throw things. You'd be the one throwing cards. Alright. Anyone have a good idea for me? What we can do? Libido, what do you think?
So this is what I did in my head. For the 3 leftovers,
Okay.
I just cut them into bits.
Ah. Okay, so Leviva says, if we want to make life easy, act like this is the only thing left over and give a piece of it to everybody. Right now, those should be in the same place because I'm not great. But 1, 2, 3, 4, 5. Everyone gets a piece. And then do that with all of them, right? So then each person's going to get 3/5. Because, I mean, what's really happening here, where are you at, is this. Right? The order shows up, and we all get 1, 1, 1, 1, 1. Another one, another one, another one, another one, another one. And then we all stare at each other and we're like, there's only 3 left. So then we either fight to the death, so either we argue or we just split them up. Now, if you long divide, you're not breaking into fifths. If you long divide, what comes after the decimal? Tenths. So if you long divide, every cheese stick has been broken up into tenths, and we each get 6 tenths, which is the same thing as 3/5. Right? So what Leviva did, totally perfect. We take the last 3, cut them into fifths, or we can cut them in tenths because we know how to do that, right? It makes sense.
Would you really spend that much time cutting that many?
I don't know. Mr. Smith, do you think we'd spend that much time actually cutting cheesesteaks? Yeah, we probably already ate them. So really, what we would do is tell the table to argue about it while we eat the rest, right?
Yeah.
Challenge. Draw. Now, different challenge. Hold up. There are now 4 of us out to eat. And we order some real fancy appetizers. Now, what we didn't realize about this fancy appetizer.
It's like $1,500.
No. There's only 3 of them.
Is it shrimp?
So, with your group, how would you physically break 3 objects evenly to 4 people? One of us left, right? There's only 4 of us now. But how do we actually show 3 divided to 4? So talk with your team. Draw out on your paper 3 objects, please. I don't care if they're circles, squares, rectangles, whatever they are. Totally fine. How do we do this? 3 objects split to 4 people. How do we do this? I will give you 2 or 3 minutes on that.
Each person gets 3 cards.
Flat red people.
Flatbreads, sure.
Each person gets 3 cards.
I didn't think of anything. I think you guys quickly figured this out.
Each person gets 4.
Riley's like, Mr. Hudson, you can just split them all into 4ths.
Each person gets 3 cards.
Right? So, person A, person B, person C, person D. And we do that with all three. So each person gets 3/4. Now, what we're trying to do is connect the idea in your head of what physical division looks like and how we get terminating or non-terminating, like repeating, decimals. The reason terminating decimals terminate is I can actually split things up into certain size pieces and distribute them to everyone. We know that a fourth piece is 0.25, right? We're used to a quarter. A quarter is 25 cents, right? We're used to that. But a third, a sixth, a seventh, these weird fractions don't terminate. They don't break up into nice decimals, and therefore we have to get better at those conversions. They're tougher.
And therefore they're even. And that's what we need, the dynamic decimals and fraction action.
That's why we need dynamic decimals and fraction action.
Scandal.
Sister snatched.
Now, I agree with Riley's method, but we don't actually like count like this. They're like 25 hundredths. When we say like, oh, cut it into fourths, like our brain doesn't really convert that quickly. So remember, if we actually did the long division, like we took the Joey route and did long division, we have to split them into tenths first. Right? So if I do that, now hang on. I'm not asking you to write, but I'm just asking you to watch. That is not what I want.
I don't like sushi.
What? Look at my
It'd be 2.5.
This is me trying to convince you not to long divide. If we long divide, first place after whole numbers, right? Nobody gets whole numbers. There's only 3 and there's 4 people. First place is tenths. So I have to cut this into tenths. They're not the same. And we distribute, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. Crap, we have 1 left over. And we give that to person A. And then we, again, split this into tenths. 1, 2, 3, 1, 2, 3, 1. Crap, we have 2 left over at the end. We do this, like, then we end up with stuff left out here, and there's not enough to be even, so we have to split those again, but what's the next decimal place beyond tenths? Hundredths, and now we're taking our flatbread, we're cutting it into 100 little pieces, and we're 1, 2, 3, 1, 2, 3, 1, 2. It's really, really annoying.
And then you're
Right.
like, man, I don't even want this anymore.
Long
It's not even a
divide.
flatbread.
Now, if avoidable. You can long divide if you want, but Hi, hey.
Sorry.
You're like talking to the wall. I don't know what's going on. Jalen.
I don't understand. Well, I do understand. But what if one person's full?
No. We're being even. We're being fair. You can take it home if you need. We're going to be fair.
Yeah,
We're splitting the check. Joey.
Why can't you just make your life easier and everyone gets their own appetizers?
That would have been a better idea.
Yeah.
But we're teachers and we have to share because we don't have a lot of money.
They don't have to share.
Alright. We're going to skip 2-4 and look at 2-5. So if you're numbering, which you should be, write down 2-5 or just 5. I don't really care that you write chapter 2. Yeah, Nathan? TGI Fridays, probably. No. Actually, we really like the food. Actually, a few places around here. I really like the food up at 101, but Crappy Pint has really good appetizers. Write down the fraction 20 over 33. We're going to stop talking about appetizers now.
You're making us hungry.
Now, I have a challenge for your team. Without a calculator, figure out the decimal value of this number. Now, that'd be a dangerous challenge. I would potentially bet money that you can throw me relatively any fraction, But I would wager a gamble, like actual money. You could throw me any fraction divided by 33, or really 11, or 22 probably, or a lot of numbers. And I could give you the decimal value like that. Not because I've memorized all of these decimal values, but because I know a couple certain rules. So, with your team, try to figure out the decimal value of this, and then I'm going to blow your mind. So, talk to each other.
What if I don't have a mind to be
There we go. Yeah. Actually, you shouldn't write that down. I mean, you can if you want, but it doesn't work.
I know it.
That is so no. It goes to 99.
Yeah, it does.
There's so.
You guys can always have post-it notes. I think I have some somewhere for you guys. I had a container of post-it notes. I just don't know where they went. Hey, Sky just asked the question, so it's worth noting that there's post-it notes over here. If you need, guys, like, all of the stuff in my room is here for you, but if you need post-it notes or color pencils or markers or all of that's over here. Ethan said something really interesting. Ethan, what did you tell me as I was walking around? 33 cannot go into 100 easily, but ooh, it does go into 99 real nice. What's that multiplication?
3
times 3. Go ahead and write this down. Which then means that the numerator
60
becomes 60. Now, we had division by 9. Joey so expertly for us repeats the thing on top. Right? Whatever was on top gets repeated when we have division by 9. You ready to have your mind blown?
Please, my mind's already blown up.
Think. Just shut your mouth for a moment. Just think. What do you predict this is going to become? Do you think it's going to become 0.6 repeating?
Yeah.
0.6 stop?
0.6 repeating.
No, it's only 5 seconds, guys, so shut your mouth and just think.
Oh, sorry.
Now, what this actually becomes.
Why did you say that? Why didn't you call on me?
Because I wasn't calling on anyone.
Wait, why? This is uncalled for.
Hold on, hold on. Even if you knew that.
How did you know that?
60 seconds. Make predictions at your group. What is 60 over 999 going to turn into? Make predictions with your group.
That's what I thought. If it's not, I'm going to repeat.
Your brain smarts?
Oh my gosh,
I guarantee you the tens place is not 6. Because think about it. Think about it. We have 60 divided by 999. I guarantee the tens place is not 6. Right? That doesn't make any sense.
Is it 10?
So, do we have predictions? Give me a hand. Do we have predictions that you want to share? Sky?
I know that it's wrong, but can I still tell you
Sure,
what we had
yeah.
originally put? We put 600, 600, 600, 600. Because we thought that you just multiplied it by 10.
Okay.
Okay.
If this was 60 over 1,000, that would be 60 thousandths, right? Like we could write that as a decimal. When we had 1/9, stay with me. I'm gonna blow your mind, I promise. We repeated one digit. When we had 1/9, we repeated one digit. When we had 60 99ths, we repeated the 2 digits.
Oh, snap. We were right.
I'm calling.
Remember when I brought up there's infinitely many zeros on each side of every number?
Yeah.
When there are 3 9s on bottom, we have to repeat 3 numbers. But 60 only has 2 numbers. So we put on the other digit. So we have 3, and we repeat 0, 6, 0, 0, 6, 0, 0, 6, 0, forever. So now, if you've picked up on the trick, or the rule, or whatever you want to say, if I give you 77 over 999, write that down and write the decimal form. Write that down and write the decimal form.
Oh, I did! Yay! Oh, I got it! Yeah.
It'll repeat 0.077. Now you can use this trick in a lot of different ways. So, pencil down for a moment, give me your eyes. Let's imagine that we're given the fraction 3/11. 11 does not become 100 very easily, right? It's kind of gross. But it becomes 99 super easy. What is 3 times 9?
6. Wait, no.
6?
No, no.
27.
My bad.
He did the difference he did a few different, his brain just connected 3 and 9. Like, there's a reason he said 6. There's a definite reason.
I thought he just said
Any denominator. Any denominator. Any denominator that can be turned into 9 or 99 or 999 or any amount of 9s, we can then apply this rule and get the decimal.
wow.
So, the biggest chunk that I wanted you guys to get today is however many 9s are on bottom, that amount of numbers repeat. So hang on, we're not done yet. I got 2 minutes. So if I gave you, let's see if we paid attention. If I gave you,
What is this?
no talking. Write down the decimal of this. You only have to write it once. Don't write it multiple times. Write it once and put the repetent above it. Is this gonna repeat?
Yes.
Absolutely.
Absolutely.
How many digits on bottom? 6. So we need to make how many digits on top? 6. So put some extra zeros here. 0, 0, 5, 4, 3, 2. Repeating bar. That's it. Have a great day, guys.
I'm so hungry. Like, if you eating, like, no,
Yeah.